Hey again guys, and welcome back. In the last video you saw me playing with these high CRI LED strips. Um, I actually built a little 1 foot by 1 foot light fixture and put these strips onto it. Um, I went upstairs and checked out my wife's streaming situation, which I think is going to be the main use of these lights, and came up with a few details. One is that a panel, even though it didn't take this whole panel, one panel's worth of LEDs is way too much. This is about 16-ish feet of LEDs, and that's way too much light. 50 watts of LED power is incredibly large amount. And on top of that, it also becomes expensive to run these things because the power supplies are not cheap if you have to buy them new, which for a full strip containing just under 4 amps of current, that that gets kind of expensive. And so I don't want to make a panel 1 foot by 1 foot with a whole roll of tape on it. It's just too much. Another thing is she needs more than one light, because just one single light source doesn't light up the green screen well enough. So I'd like 2 or 3 light sources, and if I divide this in 4, I can buy 12 volt 1 amp power supplies and run each of them on their own. The 12 volt 1 amp power supplies are like $6 each if you buy a 5-pack on Amazon, because it's like 25 bucks and some cents. So that being said, I've also figured out that I want these in 12 by 4 inch strips. Now, having a wide strip rather than a square strip isn't quite as good for light diffusion, but it does give us a few more options as to how we want our light patterns to be, more adjustability. And on top of this, don't forget that when you do these kinds of projects, you still need to mount them somehow. So I figured going 12 by 4, so 12 inches long by 4 inches wide, will give a nice compact lightweight solution. And I'm still using this foam board because, again, I do want this to be lightweight. Not sure why I put this down. I'll cut this out and I'll show you exactly what I have in mind here. Important with this foam board is you don't go all the way through in one shot. You do a couple passes without moving the ruler, and you get a clean cut. So I went a little off here, but not the end of the world. I can trim that back, or really, this will be behind the camera so nobody will see it. But here's the first panel, what it's going to look like. And I think I'm going to divide the 16 feet by 4, and that gives me 4 feet. So this being 1 foot long, I'll put 4 strips down here, kind of centered as well as I can. And then to mount it, at my local dollar store, there is this thing. So this is a clip that you put on a table and a rod, and these are jaws. And what's nice about this is it is flexible and it will stick to the shape that you give it. It's really meant for, cell phones and tablets and stuff. But I think I did my calculations correctly, and this here can comfortably hold a 4-inch wide strip of this foam board. So why go through the trouble of designing and 3D printing a mount when really a dollar's worth of, well, actually a couple pennies worth of a dollar's huge sheet of foam board and this $3 or $4 mount is all we really need. So I guess the next step up is to cut off these LED strips. Now I'm going to take this heat shrink tube off because I think I'm going to mount this my own way, or I'm going to wire it my own way. So we don't want the included wires. We'll desolder them. I'm just trying not to damage the strip. What I find really cool about these high CRI strips is they just seem higher quality. They have thicker copper, Like the strip itself is far thicker than I'm used to, because I've bought some 5630 LED strip for work before to put underneath my toolbox as lighting, but the copper wasn't this thick. This actually feels like a relatively high quality version of this. I'm gonna peel there we go. Okay, so I need to cut these into 1 foot long sections, and because I'm not quite sure if this is actual copper or what, I'm going to cut these with my old snips here. I'll just cut right through that solder section. There we go. Can do exactly one clip exactly across just one snip there. And I like that these are not quite a foot long, which means that I'll have some leftover at the end, and I'll have some space also on this sheet to work with. So again, right here, see a little scissors symbol there? It's because you can cut them here. They are meant to be cut at these locations. And one more should do it. And here we go. I think making it this way, where you end up with four of these little light units, I think that's the proper way to do this. You get a good amount of light from each one of them, and you get 4 lights. So I think when it comes time to build my lighting setup down here, when it's time to replace the big spotlight, that's probably what I'm going to do. So I'm not peeling the tape all the way back. I'm going to peel it most of the way back and then fold it over like that in a 45. I might just snip this piece of tape away like that. Get that out of the way. Line this up kind of as evenly as possible. Spaced evenly, that is. Like that. It doesn't have to be perfect, because by the time it gets all the way to your subject, it'll be pretty diffuse, so it won't be really that noticeable. This is the same thing. I don't want to peel it all the way, and I'll show you why shortly. But you see how stiff this stuff is? Like, this is thick copper. Okay, do a little triangle like that. Fold it down at a 45. And then just chop off the excess there, leaving me enough. And this one's a little bent from the fact that I had it installed on some foam board before this. And there we go. It's all the way up like that. Oh, I already made a mistake. I didn't line up the see, the negative is on this side, and the positive's on this side, and the positive's on the inside here too. So I already made a mistake, but that's not a big deal. When you do this yourself, you can pay more attention to that. I didn't. Just my wires won't look as neat. That's not a big deal. So that would be the middle. I need to scooch it over a bit. Maybe about there. Okay. And let's see. Everything's going to be aligned except for that first one. There we go. They ended up relatively even, but not super even, but that's okay. Let me get my soldering iron ready, and I'll show you why I left these unstuck. Okay, so the next step here is to cut some wire. So basically all these strips are going to be in parallel, and so I just want to cut some wire that fits from positive to positive to positive to positive, but that does so kind of with a little bit of slack. Now, the newer you are at this and less finicky you are at it, probably the more slack you want to give yourself. I'm fairly confident, and I also got a lot of wire, so if I mess up, it's not the end of the world. So I'm not going to give myself too much slack, and just a little bit. Plus, this is going on the road with my wife. She'll be doing some streaming at certain places, and therefore this needs to be kind of not have any loose ends. And I'm just going to cut a little bit longer wire for the power wire. So I'm just using a black wire to measure here, simply because to save you the tedium, I actually pre-cut the black wires for the negative. Now, the reason I left all of this loose is so I could tilt up the strips and use a metal backing to pre-tin and to solder onto these wires. So I can go ahead and pre-tin all of these spots here. So everywhere you see the copper exposed is where you can solder to. They do make connectors that sort of butt into these, but I'm not sure if that's a good idea, simply because this strip runs a lot of current. Mind you, I guess it's not bad when you're doing all individual strands like this, instead of them being all already in parallel. These have got to desolderify. Okay, put that underneath. Just, any piece of metal or silicone or whatever you can put underneath. Pull that one off. There we go. I'm going to refresh this solder with a little bit of this lead-based stuff. There we go. No danger whatsoever with the lead-based stuff. As long as you don't eat it, you'll be fine. Okay, I'm going to strip the little ends off these little wires here, and then the plan will be to pre-tin them. And once they're pre-tinned, it shouldn't take very much effort to solder them onto the little pads here. Might take a little bit of holding, but other than that, should be fine. And I'm not worried about current handling capability. These are just short runs. They're just a foot. Should be able to push an amp through 22 gauge wire at 12 volts fairly easily, but I mean, if it's going to overheat, we're going to see it sooner rather than later. Wish I had a wire stripper, but nobody sent any to my P.O. box. Looking at you, big companies. Gonna get a little solder pad here. Well, actually they're hot glue gun pads, but they work really well for soldering on. Okay, and now I just want to tin all of my connections, and once they're tinned, I can go ahead and solder them onto the lights. This solder pad, or hot glue gun pad, or whatever, solves the actual biggest problem with helping hands, and it's that I can't push down hard enough. Basically, if you solder with a strong push downwards, you get the heat to transfer a lot easier. And so the problem with helping hands that aren't bolted to the table is that I can't get enough pressure on them to get good heat transfer, because often your iron can actually has the heat required, the energy required to solder quite a heavy joint, but simply doesn't have the contact. A little bit of trimming to do here. You can tell this poor PVC wire is not handling the heat as well as the silicone mat is, because the insulation is just pulling back. Only thing left to do now is to solder onto these pads. Now I'll probably start with these long ones, simply because they're going to go sort of around and back in towards. So I'm going to solder them maybe facing upwards, but I don't want the soldering of these long ones to disrupt the other wires. Maybe I'll even go downwards, sort of like that. As long as it's not covering that LED, I think we'll be good. And there we go. And the same thing with this red one. Just twist it into a tight S-bend like that. Okay, now that these are done, now you can start linking them from one to another. So this is not easy per se, but it's also not difficult. It can be very fiddly because you really need to get these on pretty accurately, and if you stay on the connections for too long, these pieces of wire are so short that they'll actually desolder the other end. So you got to be very careful about that. But thankfully, because everything is pre-tinned, you can just quickly touch it, and that's soldered into place. Now I can give it a little bit of a bend. This will be sticking up a bit, which is fine. We're not looking for a beauty contest here. This is homemade stuff. Down like that. Let that cool. There we go. And now we need a sort of like a longer black wire. We're going to do the same thing on the negative. And it's just important that you hold down your wires as you go. So I definitely want to put contact there, and I want to hold this black wire in orientation. Okay, and I'm just going to just touch that with the iron. Boom. Because this is lead solder, it solders very easily. And then I can adjust this so that it touches, and boom. Not bad at all. Now the red one's going to be a bit trickier, so we can start with the red. Okay, we can even go downwards like this. As long as we sneak around that connection there, we can even make this into like a hard bend. As long as it's making good electrical connection, you should be good to go. Oh, touch the wire there a little bit. There we go. That is soldered on. And you can go up and around, sort of like this. If you're the kind of perfectionist that likes to cut wires to exactly the right length and And if you don't get it right, you're going to cut another piece. That's fine too. That's not my intention. It's not how I do things internally. Like, this is just for the wife, so she doesn't care about how these things look at all. If it was for a customer, that would be a different story, obviously, but it is not. I have to be a perfectionist at work. I don't have to be one at home. There we go, being very careful. Melted a little bit of the insulation there. When you make a mistake on PVC wire, you can smell your mistake. I can definitely smell it now. Right, same thing here. Just a little touch. And looks like I'm ending up with a very short wire here. So that wire was actually probably intended to go over here. But that's okay. As long as it doesn't short the other connection, everything's going to be fine. I got a little bit of PVC on the tip there, so I give it a little scrub. I need to angle this down. There we go. No problems whatsoever. One more connection to be made, and that's this guy here. I can run it over if I want, which I probably will. Go over this way. Just a quick touch. There we go. I'm going to run this underneath the black wire here and around like this. And then touch this with the iron. There we go. That is all connected. And now, the reason why we left these little ends here is that you can just peel these ends off like that. And 4. Get stuck on these wires here. Just run that underneath like that. 1, 2, 3, 4, and then press these down. Now these are stuck. Now to do a little bit of strain relief as well, I'm just going to poke 2 holes in here. 1 and 2. We're going to offset them a bit. You don't have to, but I just think it's prettier. It works better. You just push these wires through. 1 and 2. And now these wires will be out of the way. And I can decide how I want to connect them to my power supply underneath here, however I want. Just need to strip the ends, and then we can give it a shot and see how well it works. So I gave myself a little bit more wire here. Go. So I'll just strip the ends generous length, and then I can either twist them together. Whoops. There we go. I can either twist them together and solder on the power supply, or however I want. I could put a battery connector on here too. Actually, that's a good point. You can hook this up to a lithium polymer battery as long as you have some sort of way to shut it off when it gets low on voltage, and then you got yourself a portable light. So yeah, everything here is in parallel. There should be virtually no voltage drop from here to here. Each of these strips will get approximately the same voltage all the way down, and all we need to do is plug this in and see how we made out. All that's left to do now is to test it, and so I'm just going to plug it into my little power supply here. Now the reason I didn't plug this straight into the power supply 12 volt 4 amp thing I had before is because I actually want to see how much current this is drawing. We're aiming for just under an amp. I think if it's just over, it might be okay as well, considering the power supplies that are 1 amp are they could have a little bit of tolerance. If not, 1.5 amp supplies or 2 amp supplies are also possible to buy. And so let's go. So there They are on. I have a dicky connection somewhere. Oh, I think it's in here. Okay, I think it's good now. There we go, 11.99 volts, 1.4 amps. So we do have more. Just not sure where this connection problem is. Could be my bad soldering. No, I think it's over on this end. So we're actually pulling more current than we were before. And I think the reason for that is we don't have the voltage drop now across the whole thing. Not to fear, because we can just use 2 amp power supplies now. But here we go. So this is a little light, and again, it should mount without issues to this here clip, and then you have a portable light on a stand. Now, obviously, you can't use this super close because the lights are kind of spread, right? They're a little bit far apart. But by backing it up a little bit, then they'll all blend together because they have about a 180 degree field. But I'm telling you, this thing is actually quite bright. If I can flip this around. So I'll move it up so it's the same height as my spotlight. Yeah, and it's just as bright. I can see there. It's just as bright as my 50-watt spotlight. Maybe a little bit dimmer, but not too much dimmer. There we go. So this is how to make your very own portable or not high CRI LED strip light diffusion thing. And I hope that you guys will try this too. You don't need the high CRI LEDs. If you want to use the cheaper LED strips, like I have these cheaper strips here that I'll only use for lighting up underneath my shelves. You can also do this and stick them kind of everywhere in your space, but because this will be used for video recording and live streaming, basically this thing needed to be at least a reasonable CRI, and which I believe it is. Thanks again for watching.